Very pleasant good evening to all. Today, through this video, I'm going to share model paper number 4, that is exclusively section A, electronics. Already I have passed 3 model papers. With this model paper, all 4 numbers will be available in the net. Prior to this, already I have shared enough model papers with regard to communication procedure. Now my focus is on electronics part. I'm sharing all this stuff with a view to help those who wanted to appear restricted grade ham radio license and as well as general grade ham radio license. Restricted grade, this stuff is enough. For general grade, one has to practice Morse code, exclusively Morse code training, and electronics and communication sessions are going to be conducted on this summer on May 10th. Inaugural session scheduled to be held at 6 p.m. Those who wanted to join in the training, they are all welcome to crack general grade. The last batch also, all the candidates qualified. General grade, 13 people have qualified and received their licenses. This batch is also, we are going to concentrate to get as many as we can, particularly the general grade examination. So now straight away I'm moving to model paper number 4, section A, radio theory and practice. The first question is the highest frequency that is reflected by an ionosphere layer is maximum usable frequency. Alpha is the correct option. The device that can be used as voltage regulator is Zener diode. Express the gain of an amplifier in dBm when the output power of it is 100 milliwatts with reference to 1 milliwatt. So we have to find out the gain of an amplifier in dBm. The formula is, it is the formula power in dBm is 10 log to the base 10 log P out by P in to the base 10. Here P in is 1 milliwatt, P out is 100 milliwatts. So it becomes 10 into log 100 by 1, 100 by 100 to the base 10. Here we can easily calculate this log 100 to the base 10. It is 10 square. It becomes 10 square. 2 into 10 becomes 10 into 2 becomes 20. The answer is 20 dBm. So the output power is 20 dBm. The output of an amplifier with a 10 dBm gain and an input of 1 milliwatt is, here we have to find out the output of an amplifier in milliwatts. The answer is 10 milliwatt. Alpha is the correct option. Here the explanation has been given. The gain of an amplifier is given as 10 dB, and in the input power is 1 milliwatts. 1 milliwatts. We know that gain in dB is equal to 10 log P out by Pn to the base 10. Here substituting the given values, Gain is 10 dB. Already it has given 10 dB. 10 is equal to 10 into log P out by P in to the base 10. Here already P in is 1 milliwatt, dividing both sides by 10. So 10 by 10, 1, and here 10 log, it becomes, this 10 also cancels. So the remaining part is log P out by 1 milliwatt to the base 10. So we have to find out this P out, power output. Taking anti-log here in this case, P out by 1 milliwatt is equal to 10. Therefore, P out is equal to 10 milliwatts. See, this P out by 1 milliwatt to the base 10 is equal to 1 means this P out must be 10. So then only it becomes 1. Using this logarithmic formula, so P out is equal to 10 milliwatts. The transformers are rated in volt amperes. Delta is the correct option. Batteries are connected in parallel to get more current capacity. Alpha is the option. Next, the polarization of an electromagnetic wave is defined by the direction of the E field. Charlie is the option. High frequency long distance propagation is most dependent on ionospheric reflection. Alpha is the right answer. A low pass filter for a high frequency transmitter output would, this is a low pass means it will allow all the frequencies below 30 megahertz. That means attenuate frequencies above 30 megahertz. Above 30 megahertz frequency will not be allowed, that will be attenuated. So answer is alpha. The capable of a receiver to receive weakest possible signal is its sensitivity. Sensitivity is the ability of a receiver to respond to a weak signal. So sensitivity is the answer. Here, question number 11. A half-wave antenna resonates at 7100 kilohertz, approximately this long. The antenna, half-wave antenna, it will be 20 meter. So the formula here, we know the length of the antenna for a half-wave dipole is L is equal to 300 by 2f. So we know length in meters, f is equal to frequency in megahertz. So f is equal to 7100 kilohertz. That means that is 7.1 megahertz. Now calculate L is equal to 300 by 2IF, 2 into 7.1, that is equal to 300 by 14.2, that is approximately equivalent to 21.1 meters. In practice, due to end effects, it is slightly shorter, approximately 5% less. So around 10 meters. Answer is around 20 meters. Answer is 20 meter. An RF transmission line should be matched at the transmitter end to transfer maximum power to the antenna. If antenna is not matched, so there will not be transfer of maximum power to the antenna. Delta is the correct option. Here, the black marked regulator in the diagram is, so this part, regulator, regulate the incoming mains voltage to a constant value. So it is rectifier, it is something relating to rectifying circuit. So transformer, rectifier, filter and regulator, the function of this regulator is regulate the incoming mains voltage to a constant value, to the required value. It is required 12 volts, will get only 12 volts. So the function of this regulator to supply constant value. Harmonic frequencies are at multiples of the fundamental frequency. At multiples of the fundamental frequency. If 7 megahertz is the fundamental frequency, harmonics would be 14 megahertz. That is 7 into 2, 21 megahertz, and 7 into 3, 7 into 4, 28 megahertz. So all these are all called, multiples are called harmonics of this fundamental frequency, 7 megahertz. 15 SSB transmissions occupy about half the bandwidth of AM transmissions. Charlie is the right option. In the transmitter block diagram shown in the driver buffer, this section provides isolation between the oscillator and power amplifier. It is the oscillator and power amplifier. It provides isolations. So this acts like a buffer and isolating from both the sections, oscillator and power amplifier. So correct option is Charlie. Selectivity in a super het receiver is achieved. Selectivity in a superhetted receiver is achieved IF amplifier, through IF amplifier. Each of 9 resistors in a circuit is dissipating 4 watts. 9 resistors, 4 watts. 9 into 4 is equal to 36 watts. So we know the power is 36 watts. So we know that power is V into I is equal to 36. We have to calculate the total current. That's already voltage they have given as 12 volts. So I is equal to 36 by 12 is equal to 3 ampere. So delta is the correct option. In the black diagram of the receiver shown, the limiter. So the limiter at this point limits the signal to a constant amplitude. Limits the signal to a constant amplitude. Alpha is the right option. In a forward biased PN junction, the electrons flow from P to N. Alpha is the right option. P to N. P to N. A transmitter power amplifier has a gain of 20 dB. The ratio of the output power to the input power is, we have to find out P out by P in. The power gain decibels is given by the formula GdB is equal to 10 into log P out by Pn to the base 10. Here the gain is 20 from this 20. So 20 is equal to 10 into log P out by Pn to the base 10. Dividing both sides by 10, it becomes 20 by 10, 2, and then this 10 cancels. So remaining part is log P out by Pn to the base 10. Taking antilog, P out by Pn, it must be 10 square. Then only it will becomes number 2. So P out by Pn is equal to 10 square is equal to 100. The final answer is 100. Zener diodes are normally used as voltage regulators. Delta is the correct option. Here in this, a transformer with 100 turns on the primary winding and 10 turns on the secondary winding is connected to 230 volts AC mains. The voltage across the secondary is, we have to apply this formula. The transformer voltage ratio is given by V1 by V2 is equal to N1 by N2. This formula. So V1 is a primary voltage 230 that are already given. N1 number of primary turns, that is 100. N2 number of secondary turns, that is 10. So here 230 by V2, substituting these values in this, is equal to 100 by 10, 100 by N1 by N2, 100 by 10. So 230 by V2 is equal to 10. So V2 is equal to 230 by 10, 23 volts. The correct option is 23 volts. So these are the questions. 25 questions normally will be given for restricted grade. Those who wanted to qualify, they need to get 20 marks. That means they need to write correct 10 bits. So 10 into 2, 20 marks. So that is the qualifying marks. Whereas in general grade, so total questions will be 50. Out of 50, they should be able to write 20 questions. So 20 into 1, 20 marks. So these are the model papers. If you follow thoroughly, you can easily qualify a restricted and also general grade. It helps. Apart from this general grade, one has to practice Morse code. With this, now I would like to take leave. I wanted to meet you all with some other model paper, preferably that's model paper number 5. Please kindly subscribe my channel, which will helps to reach more and more people, and also it is going to be some sort of encouragement. So 73 is bye for now. Namaste.